All right. So 3.4 zeros of polynomial functions. It's a lot of work behind it. And honestly, this lesson is like, really, do we really have to do this? Well, yes, because you're going to have to do it on your test. So we already know how to find zeros. We've used synthetic division. We're going to use synthetic division in this lesson also. But there is so much more work behind it. If given, and we're just going to go over one little thing here. If I were to give you this, and I were to ask you, who is your leading coefficient? What would your answer be? -1. So the leading coefficient is a -1. Who is your constant?
4.
4. So for the first few problems, we're going to have to know what a leading coefficient is and what a constant is. So that's the main thing. So if we look at the first example, it says the rational zero theorem is used to find what kind of numbers are rational numbers? Do you remember? It could be decimals, it could be fractions, it could be whole numbers, it could be zeros, it could be everything, right? Except for the I. Those are imaginary, so those are right there. And non-repeating fractions. To find all possible rational zeros. So there's this theorem called the rational zero theorem that is used to find all possible rationals. So in the first problem, we're going to use the same example that they gave you right there on top. I'm going to look at this. And I have to know who my leading coefficient and who my constant is. So I'm going to make a little table here that says C. And you tell me my C is who? 4. Now can you tell me how can I get a 4? 1 times 4 or 2 times 2. So it could be a 1, a 2, or a 4. Those are the numbers that if I multiply them together will give me a 4. Now, who's my leading coefficient? -1. How can I get a 1? Multiplying a 1 times a 1, right? Now, all these numbers need a plus minus in front of it because I could use a -1 times a -4, a -2 times a -2, a +2 times a +2. So it could be vice versa, different possibilities. Then you're going to have to list all the possible answers. Now, what does this mean? I'm going to have to divide constant by leading coefficient. So who's my first number here for my constant? A 1. What is 1 divided by 1? 1. So my first answer is a 1. Who's my next constant?
2.
2. What is 2 divided by 1?
2.
So this could be a plus or -2. Who's my next constant?
4.
A 4 divided by 1, which is 4. This here is my answer. Now, anytime that your leading coefficient is 1, the job is easy. It's a piece of cake. But when your leading coefficient is 4, I have to do 1 over 4, 2 over 4, 3, 4 over 4, and then reduce there and work with that. So we're going to do 2 more here just so you actually see. So questions on this one? No?
You don't put the plus or minus, is it wrong?
Yes, but your answer choice is going to have plus, minus, plus, minus, plus, minus. So let's look at B. Let's say we had x cubed plus 2x squared plus 6. This is another easy one. Constant and leading coefficient.
6.
6 and 1. So which are the multiples of 6? Plus minus 1. Plus minus what? 2. plus minus
3.
3, and a plus minus 6. And how can I get a 1? Just the 1. So when I do the constant dividing by the leading coefficient, because this is a 1, my answer is just going to be what?
1, 2.
1, 2, 3, and 6, right? That's how simple that is. So it's going to be a 1 over 1, which is 1, 2 over 1, which is 2, 3 over 1, and 6 over 1. So it would be plus minus 1, plus minus 2, plus minus 3, plus minus 6. There's your answer. So we're just dividing the numbers in the C by the numbers in the LC. After we do C, if there's questions, because C is going to be the one that's going to be a little crazier. All right. So let's say we had 15x squared plus 14x minus 2. So my constant and my leading coefficient. My constant is who? Negative 2. And my leading coefficient? 15. So how can I get a 2? 1 and 2, right? How can I get a 15? 1 times what? 15. And then? I forgot to put the plus minus. So 5 and 3 or 3 and 5, right? 3 and 5. So this one, because you have more than one thing, your leading coefficient, you're going to have a lot more answers. So when I start this one, constant divided by my leading coefficient, the first one is 1 over 1. Then I have 1 over 3. And then 1 over what? 5 and 1 over 15. Do any of those reduce? Well, the first one, 1 over 1 is what? 1. So 1 plus minus 1/3 plus minus 1/5 plus minus 1/15. And then you do your second constant, which was what? 2. So now let's do 2 over 1, then 2 over 3, then 2 over 5, and 2 over 15. Do any of those reduce? 2 over 1 only, right? So then we'll just add, that's a 2, that's a 2/3, that's a 2/5, and that's a 2 over 15. If it reduces and it repeats, you don't have to write it down. Questions on that one? No? Are you sure? So try this one on your own. D will make it 2x to the 5th minus x to the 4th plus 7x squared minus 12. So try to do that one. Do your constant, do your LC. I'm hoping you listed all those because 12 has a lot of multiples. constant C over 2. So after I do 1 over 1 and 1 over 2, then I have to do what?
Oh,
2 over 2 and? Oh, just kidding. 2 over 1 first, right? Yes. 2 over 1 and then 2 over 2. Now, 2 over 1 reduces to what? 2. And 2 over 2?
1.
1. But do you already have a 1 there? So you don't have to worry about that one again. And then we do 3 over 1 and 3 over 2. That's a 3. That stays. 4 over 1 and 4 over 2. Do I have to put, what is 4 over 2? 2, but it's already there. So you don't have to do it. So I'm going to stop right there to still give you a chance to finish, but this is the idea behind if a number repeats. So this one repeated because it was going to be 1 again. This one repeated because it was going to be 2, but you already have them there, so you don't have to write them again.
Could we if we wanted to?
You can, but don't expect for it to be repeated in your answer choice. Because a lot of times when you rewrite them in your answer and then it doesn't repeat in your answer choice, you're like, oh, that can't be it. So then we have 6 over 1 and 6 over 2. And what is 6 over 2? 3. So we don't have to do that. And then we have 12 over 1 and 12 over 2. But 12 over 2 is what? 12. No, 12 over 2 is 6. I know. Sorry. So that's a 6, so we don't have to redo it. So this here would be your answer. Yes.
We have to put it in that order because you went 1 over 1 and then you did 1 over 2. Can we just do 1 over 1 and then 2 over 1?
You can.
Keep the whole order.
So you want to do this. It doesn't matter which way you do it. I like to take the first one over both of those, the second one over both, the third over both, as long as it gets done. In your assignment, let me see how they put them. You see here, they put all the fractions and then all the whole numbers. So it just depends. As long as you find each one, like when you look at your answer choices, check, make sure they're all there. That's it. So this is for problems 1 and 2 in your assignment. 1 and 2. Okay. So for example 2, we're going to use Descartes' sign rule or rule of sign. What does it say? Rule of signs. These 2 problems that we're going to do from this section are also pretty simple. It's not that bad. So let's say you got this problem first because we're going to do 2. Let's say you got x cubed plus 2x squared plus 5x plus 4. So what you're going to be doing in this problem is trying to see how many times does your sign change from term to term. That's what it's called, the rule of signs. Now, this is going to tell you how many positive zeros and how many negative zeros you have. So for the positive 0, 1, you take it the way it is, like it is right there. Now, this is what kind of number? Positive. Is there a sign change here? Is there a sign change here? Is there a sign change here? So because there is no such thing, then the answer should be there is no positive zeros. Or sometimes it'll just say there is 0 positive zeros, whichever way you want to see it. So we're looking for sign changes. Now, to find out how many negative zeros you have to, so for negative zeros, you replace the x with a negative x. So we have to replace every x with a negative x. So what does that mean? I'm going to take this problem that we had, negative x cubed plus 2 negative x squared plus 5 negative x plus 4. So every x in your original problem gets replaced with a negative x. Are we good with that? So now we look at the first one. What is negative x to the third power? It stays as a negative x cubed. Now, what happens when you have the negative x squared? It becomes positive, and then times a positive 2, it stays what? It stays a positive 2x squared. And then what is negative x times 5? Negative 5x, and then plus 4, because we don't do anything there. So once you have done that, we check. Is there a change here? Yes. So I'm going to put a 1 here. Is there a change there? Yes. Is there a change there? Yes. So how many changes are there? 3. When you do this and you end up with a number that is 2 or greater, you have to subtract 2. So what is 3 minus 2? 1. So my answer is really there is 3 or 1 negative zeros. So if you look at your answers, at your question number 3, you could see the way your answers look. They actually say number and then they say negative 0, positive 0. Are we okay with that? So your answer is going to be both this and this put together. So let's try one more and then you'll do your problems. In a little bit, let's say we had x cubed minus 2x squared plus 5x plus 4. So this is your original one. From here to here, is there a change? Yes. From here to here, is there a change?
Yes.
From here to here, is there a change? No. So how many changes do I have? 2 or 0. Because what is 2 minus 2? Remember I told you, you have to subtract 2. So let's say it was a big equation and I ended up with a 7. It would be 7 or 1. And then you stop right there. You can't go into the negatives. You either stop at 1 or 0, but you have to keep going until you get there. So this is positive zeros. And once again, to do the negative, it becomes negative x cubed minus 2 negative x squared plus 5 negative x plus 4. So the negative x cubed becomes what? Negative x cubed. The negative x squared becomes a positive, but what does it have in front of it? So it stays a negative 2x squared. The 5 times the negative x becomes a negative 5x, and this stays a positive 4. So I look at this. Is there a change?
No.
Change?
No.
Change?
Yes.
Yes. So there is 1. Is there going to be or something? So there is just 1 negative 0. And just one little thing I want to point out, because we're going to need it for the next example. How do you know how many zeros you're going to get total? Which number do we look at? Does anybody know? It is the leading, not the degree. It is your degree, the biggest degree that you have there. So there's 3, right? So here's 0, but then more than likely, how many am I going to have right there? 3. This says 3, so it's probably this 2 and 1. And what's 2 plus 1? The 3 that you're looking for. So right now, work on problems 3 and 4. So for example, number 3, it's going to be long. On your assignment, it's going to be a lot easier, but you need to learn how to do it this way for your test. So they're going to give you an equation. They're going to ask you, can you please find all the zeros? What we did in example 1 and 2, we're supposed to do here. There's a purpose why we find all those plus minus things. There's a reason why we choose if it's positive or negative. And this is where I'm going to show you what's behind examples 1 and 2. So first thing here is who do I ask for first? My constant? Who's a constant here? 6. How can I get a 6?
1 times 6. 2
Uh-huh.
times 3. Oh, 3 times 3, 3 times 3.
It's 2 and 3, right? Sorry. So 2, 3, and 6. Who's my leading coefficient? 3. So plus minus 1 and a plus minus 3. So I have to list all the numbers, like what we did in example 1. So it's going to be 1 over 1, which is 1. And then 2 over 1, which is 2. 3 over 1, which is 3. 6 over 1, which is 6. Whether you do it this way or the other way, we're still going to get the same numbers. Now, if I do 1 over 3, what is that? 1/3, right?
Yeah.
What is 2 over 3? 2/3. And then when I do 3 over 3, that is what? 1. So I don't have to write it down. 6 over 3? 2. It's already there. So these are all the possible answers that I know could be the zeros for this equation. Now, how many zeros are there in this equation? 4, right? Now, after, this is what we learned in example 1. In example 2, I'm supposed to take the original problem, right? And see how many times it changes. Is there a change here?
Yes.
Is there a change there?
No.
Change here?
Yes.
Change here?
No.
No, right? So how many changes are there? 2 or 0 positive zeros. And then I was supposed to go back and plug in who? A negative, right? So 3 times the negative x to the 4th minus 11 times the negative x to the 3rd minus negative x squared plus 19 times negative x plus 6. So the negative x to the 4th becomes 3x to the 4th. The negative x cubed is a negative, but what does it have in front of it? So it turns into a positive. Negative x squared becomes a positive, but what's in front of it? A negative, so it stays negative. 19 times the negative x and plus 6, right? So then change, yes, change, yes. So there's going to be 2 or 0. Oh, gosh. Oh, yes, negative zeros. Thank you. So we have to find the zeros. And the easiest way that we found to find the zeros in the previous lesson was using synthetic division. Do you remember doing that? We're going to have to use synthetic division now. Now, everything we're going to do is based on the original problem. So which are my numbers? 3. Who is next? Negative 11. Negative 1. 19 and 6. I have to use numbers. I know by looking at that, 2 of my answers may be positive, 2 of my answers may be negative because it says 2 or 0, 2 or 0. So by looking at these numbers in the box, which one do you want to try?
1.
Let's try 1. So we come here, we try a 1. Remind me how to do this. Bring down the 3. This becomes a 3. So this is a negative 8. This becomes a negative 8 times 1. Negative 8. This becomes a
-9.
-9. This is a,
-9.
and then that right there is a
Positive
10. That's a 10, and that's a 16. So can the 1 be your answer?
No.
So guess what? That's not my answer. So which one do you want to try next? 3. So I have to, because we did a boo-boo, it's not right, have to redo this. And we have to try a 6. That's one you wanted to try, right? 3, sorry. Just kidding. Let's try a 3. All right, so we bring this guy down. 3. This becomes a 9. Then that becomes a what? -2. -6. -7. -21.
No, it doesn't.
-2. -6.
0.
It gives you a 0. So we already found one answer, one of the what? Positives. One of the positive answers. So there has to be another positive number out there. Do you want to keep working with the positives? Do you want to try negative? You tell me what you want to try next. What do you want to try?
2.
A positive 2? Let's check that out. So we bring this guy down. 3, 6. That's a 4. 4 times 2. 8. That becomes a 1. 1 times 2 is 2. And now I get a 0. So you already found your 2 positive answers. The 2 positive zeros are
3 and 2.
2 and 3, 3 and 2, right? So when you are trying numbers still, will you try any more positives? No, because you already found. That's the whole purpose behind this here. You already found 2. So the only ones that I have left over are what? Negatives. So what do we want to try? A negative who? Take a pick.
-6.
Negative what? I heard a beautiful number over here. -1. Let's try -1. 3, -3. That's a 1. That's a -1. That's a 0. Perfect. So we already found one of my negative answers. There it is. So now I just have 3 and 1 left over. But my answer could be a -2. Or did I already try -2? No. It could be -2, -3, -6, -1/3, -2/3. Which one do you think? -1/3? Let's see. We bring down the 3. What is -1/3 times 3? -1. Is that my answer? Yes. So on your test, you're going to have to do this. On your worksheet, they already give you, hey, look at your answer choices. It's based on whatever your answer choices have. But on your test, you are going to have to do this. And maybe you're going to try all of them and you're not going to find it until the very end. Are we good?
Yes, ma'am.
So let's try one more. This is going to be B. We're doing x to the 4th minus 3x cubed minus 2x squared. Oh, just kidding. That should be a 20. 20x squared minus 24x minus 8. So once again, when you do your worksheet problems, you don't have to do the first 2 steps here. Just base it on your answers. But on your test, you're going to have to know how to do this. So the first thing we did in example 1, who's my constant? 8 or -8? Which are the factors for the -8? 1, 2, 4, and 8, right? Okay. How about for 1? It's just 1. So who are all my possible zeros?
1, 2, 4, 8.
Right? So the good thing is we don't have fractions. Yay. So these are all my possible zeros. Now, how many zeros are there for this equation? 4, because that is your degree, right? The big degree. The degree of the leading coefficient. Now, looking at the original one, is there a change here?
Yes.
Yes. Is there a change there? Change there? Change there?
No.
So there's only
One.
one positive 0. When I put in the negative, when I put in the negative x for all of them, the first one becomes positive. Then that becomes a negative, but times a -3, it becomes a positive. That becomes a -20 x squared plus 24x minus 8. Change? Nope. Change?
Yes.
Yes. Change?
Yes.
Yes. Change?
Yes.
Yes. So here we have 3 or 1, -0. So I have to keep this in mind when I'm doing my work. There's either 1 positive, 3 or 1. Now, just so you know, sometimes, even though it says 1 and 3 and 1, it could just be 1 and 1. And if I have 1 and 1, how many is that? 2. But I'm supposed to have how many? 4. They're supposed to be 4. The other ones are going to be imaginary ones. So this is going to get to a point where you have to use your quadratic formula. And that's going to be the case here. So let's set up the synthetic. 1, -3, -20. 1, -3, -20, -24, and a -8. So I will start off using negative numbers because there's more. Now, which negative number do you want to try? -8? Okay, let me see this. This becomes 1, -8, -11, positive 88, 68, and that's just going to be a huge number. So it's not going to be a -8.
-1.
You want to try -1. 1, -3, -20, -24, and a -8. Which one are we trying? -2?
1.
-1. Okay, so we bring down the first one. This becomes a 1, -1, and this is a
-1.
-4. This is a positive 4. This is a 16. This is a -16. -16 and -1 is a positive 16. This is an 8, -8. And then this becomes a positive 8, and that's a 0. So -1 is one of your negative answers. Perfect. Can we try another one?
-2.
Let's try a -2 then. We bring down the 1, -2, -6, positive 12, -4, positive 8, and a 0. Perfect. Now, there's already a -1 and a -2. Well, the thing was, if there is a negative, it's either going to be 3 or 1. So that means there has to be another what? Another negative. Now, we already tried -8, -1, and -2. Which one is there left to try? A -4. Let's try the -4. Bring this down. This is a 1. This is a -4. This is a -10. This is a 40. Is that going to give me a 0?
No.
No. So how in the world is there a negative answer? Well, this is going to be the situation now. I'm going to have to take these numbers here. So is everybody on board? Because this is where it's going to be different.
You don't get the 0, right?
we didn't get the 0, so 4 is not the answer. So I have 1, -6, and -4 left over, right? This is your A, this is your B, and this is your C. So I have to use the
Quadratic formula.
quadratic formula. X equals -b plus minus the square root of b squared minus 4ac all over 2a. So I have to use a quadratic formula, and I'm going to zoom into this so y'all can see it better. In problems 6 and 7, you're going to have to use a quadratic formula, and you're going to see it based on your answers. Now, what's a -6? It becomes a what? A +6 plus minus 36, because that's 6 squared. And what's 4 times 1 times 4?
16.
So 16, it should be a positive because of the negative, the -4, over 2. So 6 plus minus 52 over 2. 52 comes from 4 times 13. The one on your worksheet is going to be a lot easier. So the square root of 4 is what? 2 square root of 13 over 2. And what is my answer here?
X plus minus square root 13.
3
Divided
plus
plus 102.
3?
plus minus
Oh,
square root
yeah.
13.
Very good. So please remember that right there means it is 3 plus the square root of 13, which is going to end up being a positive number, and 3 minus the square root of 13, which ends up being a negative number. So did I get my 3 negative answers?
Yes.
Yes. The 2 that we had plus this one, did I get my 1 positive answer?
Yes.
Yes. So your assignment would look -1, -2, 3 plus the square root of 13, and 3 minus the square root of 13. And that would be your answer. So number 5 is an easy one. On 6 and 7, you have to use the quadratic formula. So this is enough for you to do 5, 6, and 7 right now. Let's get to work. 5, 6, and 7. For example number 4, you have to find the polynomial. So here they're going to give you some information. They will give you that your leading coefficient is -2. They would give you that your degree is 3. And they're going to tell you that your zeros are -5 and 4 plus 3i. When we cover the i's, we covered that conjugates. So not only is there supposed to be a plus 3i, but there's also supposed to be a minus 3i. I don't know if you guys remember that, but you need to have both a positive and a negative. Now, when you're looking for the zeros, because they give you the zeros, you have to start with the factors. If this were the factor x plus 5, you set it equal to 0, that's how you would get to -5. Because these 4s are positives, the next one would be x minus, but because there's 2 things, I have to write it like this. And then the other one is x minus a 4 minus a 3i. So the first thing we have to do is get rid of this parentheses. So this becomes x minus 4 and also a minus 3i. Here it becomes an x minus 4 plus 3i. When we distribute to both of those. And please don't forget that we have the x plus 5 here. Now, next way to rewrite this would be this stays like this, but we're going to have to work with all this first. So I'm going to regroup x minus 4 from here and a x minus 4 from the other side. And then what do you have left over? An addition of a negative 3i and the positive 3i. So I took this, put it right there, took this, sorry, not put it there, put it right there, and then later I took the 3i, negative 3i, and the positive 3i, and we put it like that. So now I have to work with the FOIL in here. So x times x, x squared, x times a negative 4, negative 4x, negative 4 times x, negative 4x, and negative 4 times a negative 4 is a positive 16. Please don't forget to multiply these. A negative 3i times a positive 3i is a negative 9i squared. Do you guys remember what we're supposed to do with an I squared? Now also don't forget to keep bringing that x plus 5 down. So this becomes x plus 5, x squared. These two become a minus 8x. Now, working here on the side, an I squared is a negative 1, so this becomes a plus 9. But you also have a 16 plus the 9, which gives you a plus 25. Now I have to continue and multiplying those two. So I have x times x squared, x cubed, x times negative 8x, negative x squared, x times 25, plus 25, 5 times x squared, 5x squared, 5 times a negative 8, negative 40x, and 5 times 25 would be 125. So from here we would combine like terms. So the x cubed stays. This is an x squared, this is an x squared, so this becomes a negative 3x squared. We only have a negative 40x. But then we have to, oh, I forgot to put an x here, guys, actually. So sorry. So because there is a 25x from x times 25, I have to add 25 minus 40, which gives me a negative 15x plus 125. So I have done everything. This will be one of your answer choices, but it's wrong because please don't forget we have a leading coefficient of negative 2. So everything has to be multiplied by negative 2. So this becomes a negative 2x cubed, a positive 6x squared, a positive 30x, and a negative 250. A negative 250. So this here would be your final answer. So when you look at your number 8, they give you the same thing. Just follow every single little step that we did there. Now, the next one here is a lot easier. It's less work. So we're going to say we have a leading coefficient of 1, a degree of 4. Your zeros are going to be 3i, 2, and negative 2. Now, remember, if they tell you you have a 3i, you also have a negative 3i, the conjugate of it. So when I set this up, I'm going to do these guys first. So I know this is going to be x minus 2 and an x plus 2. I'm going to have an x minus 3i, but also an x plus 3i. So this one's a lot easier because there is not a number being added to your i's. So when I look at this part, I do FOIL. X squared plus 2x minus 2x minus 4. So that becomes x squared minus 4 because these two cancel. I have to do FOIL on the other side. X times x, x squared, x times 3ix plus 3ix. Negative 3ix times a negative 3i times an x, a negative 3ix, negative 3i times a positive 3i is a negative 9i squared. Now these two cancel. So I have, so this is together, and here I have x squared minus 9i squared. But please remember what we do with the I squared. So it's a negative 9 times a negative 1, which gives me a positive 9. So this is really x squared plus 9. And this is an x squared minus 4. Then we do FOIL. X squared times x squared, x to the 4th. X squared times 9, 9x squared. Negative 4 times x squared, negative 4x squared, negative 4 times a negative 9. Sorry, negative 4 times a positive 9 is a negative 36. We combine these two guys, x to the 4th plus 5x squared minus 36. I look at this, my degree is 4. I need my leading coefficient of 1. So when I put a 1 there, it doesn't make a difference. So then this is my final answer. So this is for problems 8 and 9. See them once, see them twice, especially the first one because it's a lot more work, but it's not that bad. So please, please be careful. Those of you who need to see another example just of setting this part up, I'll do one in the bottom. If not, just go ahead and do 8 and 9. So let me just throw this out here. Let's say your zeros are a 6 and a 2 plus 5i. So let's just say this is what they give you. So because they give you a plus 5i, I also need to do a 2 minus 5i. So when you set them up, since this is positive, it's going to be a minus 6, x minus 2 plus 5i, and an x minus 2 minus 5i. Distribute the negative, negative 2, negative 5i. Distribute the negative, negative 2, and a positive 5i. Then remember, we're going to take this and this, but this is together for right now, plus, now we'll take this and this, negative 5i times 5i, and then you do the FOIL here, multiply that and combine it. So I'm just helping you in that little part, but please go back and work. Look at the notes, look at the previous problem. So work on 8 and 9 so we could be done.